Hi students, friends, good afternoon to all. I welcome you all in this fluid mechanics lecture. So let us begin. In the last lecture, we have studied this point, we have started this point, and that is loss of energy or loss of head in the pipes. This point we have started, and we have seen that the losses which occurs in the pipe, they can be divided into categories. So one is called as the major losses, and other types of losses, they are called as the minor losses. Major losses are also called as the head loss due to friction. The losses which takes place due to the viscosity in the pipe, that type of losses, they are called as the head loss due to friction or major losses. And in minor losses, we have different types of losses that we are going to study in details in next coming slides. In the major losses, we are seeing we have seen in the last lecture the derivation for the Darcy-Weisbach equation, Darcy-Weisbach formula, and in today's lecture we will see the Chezy's formula. Right, frictional losses in the pipe. That is the first point here. We have seen the various laws of fluid friction, right? 4 5 laws statements we have seen regarding the laws of the fluid friction, and then we have derived the equation for the head loss due to friction, that is Chezy's form, that Darcy-Weisbach equation were derived, and that equation was 4 FLV square upon 2ZD, right? That was the equation that we have derived. In this equation, HF is nothing but it is the head loss due to friction. Then this F is nothing but it is coefficient of friction. L is the length of pipe. V is the velocity of flow. D is the diameter of the pipe, and G is the acceleration due to gravity. And if you have been given with the friction factor instead of giving the coefficient of friction, at that time you can use this formula, HF is equal to FLV square upon 2ZD. This formula, it can be used when the friction factor is given at that time. Now let us see the equation for Chezy's formula. So equation for the Chezy's formula, it also depends upon this particular half derivation of the previous Darcy-Weisbach equation. HF is equal to F dash upon rho Z into P upon A into L into V square. So from here we can begin this derivation for the Chezy's formula or Chezy's equation. 1 minute. So now let us see here how to derive this equation from this particular part. So in fluid mechanics, we have one term which is called as the hydraulic mean radius. Hydraulic mean radius, in short, we call it as a HM. Hydraulic mean depth. This is called as the hydraulic mean radius or hydraulic radius or hydraulic mean depth. Okay, or in short, it is also called as HMD. And it is some author use the notation M to represent this term, and this hydraulic mean depth, hydraulic radius is nothing but it is the ratio of weighted area to the weighted perimeter. Whatever this perimeter is there, whatever area is there, you take this ratio A upon P. Suppose liquid is flowing through a pipe. Okay, then whatever may be the area of the pipe, weighted area means the area which have been become wet. So that is weighted area divided by its perimeter, weighted perimeter. So that is called as the hydraulic mean depth, HMD, or it is also called as hydraulic radius. Okay, and here area of the pipe is pi by 4 d square, pi by 4 into d square, and perimeter or circumference of the surface pi into d. So this pi will get cancelled with this 1d will cancel it here, and you will get here the term as d by 4. So this hydraulic mean depth or hydraulic radius is nothing but it is the d by 4. So we can call this as a hydraulic mean depth or hydraulic radius d by 4. Okay, and instead of now in this equation, instead of this p upon a, there is a p upon a in this equation, and here we have written m is equal to a upon p. If I take this p in the denominator here, the denominator मध्ये जर खाली घेतलं तर हे असं आपण लिहिता येईल. ठीक आहे. So instead of this p upon a, I can write here 1 upon m. Okay, so in this equation I am going to put 1 upon m in this equation, and let us see here Chezy's formula for the head loss due to friction, right? And here you can see the that equation directly it has been taken here. HF is equal to f dash upon rho z into p upon a into L into v square, right? This a upon p is nothing but it is also called as the hydraulic mean depth, or it is called as the hydraulic radius, and it is denoted by letter m. Okay, some author use the notation m, and some author they use the notation r to represent this hydraulic mean depth or hydraulic radius. Okay, then this m is nothing but it is the ratio of a upon p, and just now I have told you how it will equal to d by 4, and a by p is nothing but it is equal to m. So p by a, it will be we can write it as 1 upon m. So we put this value in this equation, and we get the equation as hf is equal to 4 f dash upon rho z into L into v square into 1 upon m. Okay, instead of this term I have written here 1 upon m. Now here what I am doing, I am rearranging this equation. So take this v square on the left hand side and this hf on this side. So you will get here or keep this v square here, and all other terms you take this on this left hand side. Then you will get this equation like this: v square is equal to hf. This rho z will go here in the numerator. This f dash will go in the denominator. So you will get this term. Okay, then this m will go in the numerator. And this L, it will go in the denominator. So this we can write here 1 upon L like this, and into m, this m over the. So this equation will become like this: v square is equal to hf into rho z upon f dash into m into 1 upon L. Now again rearranging the terms, hf, take this hf here, hf upon L. So hf upon L, it will become now loss of head per unit length. We can call this terms hf upon L as head loss per unit length of the pipe. Okay, and this rho g upon f dash, I have taken it here like this. Now taking the square root on both sides, दोन्हीचा square root घ्यायचा. Numerator मध्ये left hand side ला we will get here v, and in the right hand side we will get here under root of rho g upon f dash into under root of m into hf upon L. Okay, these terms we will get after taking the square root. So you can see here, taking the square root, we will get this, separate this out, and this one. Now this under root of rho z divided by f dash is nothing but it is a constant in this terms. These are the constant things. So this constant c is called as the Chezy's constant. Okay, so the scientist who have found this derivation, he has given that constant name as a Chezy's constant equal to c. Okay, and hf upon L, so this is nothing but it is the loss of head per unit length of the pipe. So therefore instead of that he has used the term I. Some author they use the notation S for denoting this I or S, both are same thing. So where I is also known as the loss of head per unit length of the pipe, head loss per unit length. Okay, means for one particular meter length, suppose this is the head, then how much head is it is losing there. So this is nothing but hf, and this is nothing but L. So this ratio of this hf upon L, so that will be nothing but I. Okay, hf upon L. Okay, so this is the hydraulic loss of head per unit length. Now instead of this term, now I am going to put here I, then this equation can be written as, and instead of this term we are going to write there c. So this equation can be written as v is equal to c into under root of m into I. Okay, so this is the equation we call it as a Chezy's formula or Chezy's equation. Okay, what is that? V is equal to c into under root of m I. Okay, this is the final equation. Some author, they use the notation for the hydraulic radius, they use the notation R, and for the loss of head per unit length, they use the notation S. So this equation can be written as V is equal to C into under root of RS, where R is the hydraulic radius and S is the loss of head per unit length, or it is slope. This was the slope which represents the loss of head per unit length. 1 मीटर लेंथ साठी किती हेड त्या ठिकाणी लूज झालेला आहे, लॉस झालेला आहे. So that is nothing but slope, head loss. This slope, it represents the loss of head per unit length. So this was about the Chezy's equation. Now after this, now we are going to solve some problem based upon this hydraulic Darcy-Weisbach equation and Chezy's equation. And before that, you note down this formula for the Chezy's equation. Okay, write down the title: Chezy's formula for loss of head due to friction in pipe. Chezy's formula for loss of head Chezy's formula for loss of head due to friction, and directly come here, write down this equation: V is equal to C into under root of mi, or V is equal to under root of Rs, C into under root of Rs. Okay, and write down there where R is equal to hydraulic mean depth, or HMD. Here M oblique S, M oblique R, and I oblique S. And this is nothing but A by P. M is equal to hydraulic mean depth, or hydraulic radius, which is equal to A by P, or is equal to D by 4. Okay, right, like this. Then I or S is equal to HF upon L is equal to head loss per unit length, loss of head per unit length. That is nothing but HF upon L. Is it over? See, by seeing this equation, B is equal to C into under root of mi, or B is equal to C into under root of Rs. The question may come in your mind. Some of the students may think that we are writing here the equation for loss of head or head loss due to friction. But if you see there in this equation, you will not observe loss of head anywhere. This equation is for velocity. V is equal to C into under root of Rs, right? Then how this head loss we are going to find out? So the answer for this question is here, because this M or this I or S is nothing but it is the HF per unit length, head loss per unit length. Okay, and if once you get the value of S or I, then you can use the formula HF by L, right? Then multiply this S or I by L, then you will get the head loss due to friction for that pipe, right? In this way we have to find this Darcy-Weisbach equation, that which we have seen, HF is equal to 4FL V square upon 2ZD. This equation, it is commonly used for finding the loss of head due to friction in a pipe flow. And this Chezy's formula or Chezy's equation, it is applicable both for pipe flow as well as for the open channel flow. हा जो फ्लो आहे, the equation आहे, it can be implemented useful for the designing or finding the head loss due to friction in open channel flow. You should know what is the same, what is R. That's why we have written it in details. I think everyone has written this. Is it over? Kedar Patekar. Kedar? Kedar, are you listening to me? Unmute yourself. 1 minute. Kedar, unmute yourself. Unmute yourself, Kedar.
Hello.
What is your roll number, Kedar?
57.
Why you have not put your roll number in the name, in front of your name? Write down there, SA 57, roll number. Change that name there. Because while taking attendance, it will remain there without taking attendance. Though you have attended the lecture, you will be marked as absent instead of that. So it is better to put your roll number there. So everyone, have you written this thing in your notebook?
Hydraulic radius सांगा.
Hydraulic radius. अजून एकदा सांगायची का?
हां सर.
Hydraulic radius or hydraulic mean depth is nothing but it is the ratio of weighted area divided by weighted perimeter. Okay, that is nothing but M, or sometimes R is also used. R is equal to A by P. Weighted area, weighted perimeter. What is this meaning of weighted area, weighted perimeter? Weighted area is nothing but जेवढा area ओला झालेला आहे, okay, किंवा ओला होऊ शकतो, that area is called as the weighted area. In case of pipe, the whole area may be get weighted. So we take their area of the circle, that is pi by 4d square. Okay, that is weighted area. What is weighted perimeter of the circle? It is nothing but circumference of the circle. So we divide it by circle, pi into d. This pi will get cancelled here. This d will even get cancelled here, and we get here d by 4. Okay, so the same thing we have written here. A upon P is equal to d by 4. In case of open channel, suppose the channel is rectangular in section, okay, and if you want to find out what is the weighted area and what is weighted perimeter and R, or hydraulic mean depth, then how we can find? We can write here area is equal to B into D. Suppose this is B is the width and D is the depth. Then perimeter will be what? Perimeter will be equal to this depth plus this width plus this particular depth. So I can write here B plus 2 into D. Okay, so here I can write M is equal to hydraulic mean depth is equal to A by P is equal to B into D, BD divided by B plus twice D. Okay, so this will be the formula we can use for finding the hydraulic mean depth or hydraulic radius in case of rectangular channel. Channel can be trapezoidal also. If the trapezoidal channel is there, in that case again the formula will be different. Suppose this is the A, this is B, and H is the height here, or D is the depth. Then what will be the area of this trapezoid? A plus B by 2 into D. This is the area. What will be the perimeter here? Perimeter area will be equal to this. Perimeter will be equal to this slope, length of this slope plus this plus this. Okay, that we need to find out, and we have to put it here. And then finding this divided area by the perimeter to get the radius, hydraulic mean depth or hydraulic radius. Okay, समझला?
Yes, sir.
Okay. Now we will solve the problems here. Write down the problem number 1 here in this particular case. Loss of head due to friction. Find the head lost due to friction. Find the head lost due to friction in a pipe. Head lost due to friction in a pipe of diameter 300 mm, of diameter 300 mm and length 50 meter and length 50 meter, through which water is flowing, through which water is flowing at a velocity of at a velocity of 3 meter per second, 3 meter per second, using first Darcy formula and second Chezy's formula. First Darcy formula, second Chezy's formula, for which C is equal to 60. For which C is equal to 6060. Take V is equal V for water. V, it is not V, it is nu. Take nu for water is equal to 0.01 stoke. Take nu for water is equal to 0.01 stoke. Yes, how to solve it? First of all, write down the given things. Given diameter of the pipe D. Diameter of the pipe D is equal to 300 mm or 0.3 meter. Length of the pipe L is equal to 50 meter. Then velocity. So this velocity is the average velocity actually. 3 meter per second. Okay, and C is equal to 60. Then nu is equal to 0.01 stoke. Nu is not required anywhere, but they have given it. I don't know why. Sometimes they don't. They give the data which is not required also to confuse the students. Okay, this may happen. Now let us first use the formula. First formula is Darcy formula or Darcy-Weisbach equation. What is that formula? Who will tell? HF is equal to what? Yes, anyone? Snehal?
Yes, sir.
Tell the formula. HF is equal to? Not written. Roll number 8.
Yes, sir.
Where the this in between students to roll number 2 to roll number 7, where they have gone? Why these students are absent? I have to submit your present towards your CC so that he will take the follow. See, this kind of negligence is not allowed because your syllabus has increased. I have told you. Yes. Wait. Shweta,
Yes, sir.
tell me.
F dash into E into L into mu square upon rho G into A.
F dash into repeat it once again slowly. सुरुवातीपासून सांगा अर्धच का सांगते फॉर्म्युला लेफ्ट हँड साइडला काय रोल नंबर 8
Yes, sir. Wait.
why to wait आपला फॉर्म्युला पाठ झाला पाहिजे आतापर्यंत तुम्हाला येत नाही फॉर्म्युला ठीक आहे दुसरं कोणतरी सांगा रोल नंबर 3 सायली भोसले वेर यू वेअर तुम्ही कुठं होता इतके वेळ रोल नंबर 3 अनम्यूट
Yes, sir.
हा तुम्ही कुठं होता इतके वेळ आता जॉईन झाला तुम्ही लेक्चरला
Sorry, sir.
काय झालं प्रॉब्लेम कंप्लीट हाफ एन आवर लेट का प्रेझेंट द्यायला यायचं तुम्हाला
नाही सर काम होतं
काम होतं लेक्चर पेक्षा तुमचे बाकीचे काम महत्वाचे लेक्चरच नाहीत महत्वाचे
नाही सर सॉरी सर
सांगा तुम्हाला फॉर्म्युला माहिती आहे का डार्सिस विक इक्वेशन yes see how much careless we behave your parents are paying huge fee to the college they are spending a lot of money on you and how we are giving response what kind of output you are giving to the parents is it the way of learning how much careless you are behaving all the students not except particular one student I am asking I have asked you a simple question formula for the hf is equal to what that student roll number 8 Shweta she don't know she has told something and then she has kept quiet roll number 3 she is also not able to tell the formula तुमच्यापेक्षा तो डायरेक्ट सेकंड इयरचा क्लास मला जरा चांगला वाटतो ते रिस्पॉन्ड तर करतात प्रत्येक वेळेस प्रश्न विचारले कोण ना कोण उत्तर देतो तुमच्या क्लासमध्ये तसं नाहीये खोदून खोदून विचारलं लागतं असं वाटतं की तुम्हाला काय गरजच नाही शिकायची yes why B division students they are more active than your class तुमच्या क्लासमध्ये असे वळून पकडून आणून बसवल्यासारखे वाटतात लेक्चरमध्ये लोक. And you don't have the seriousness. I don't know what is the reason behind this. Or that diploma students have the more maturity than you because they have done the diploma. Though they don't know the answer, they will ask, or they try to tell the answers. And I never told that if you don't know the answer, then don't tell. तुम्हाला उत्तर येत असून तुम्ही गप्प बसते तुमच्या क्लासमध्ये असले विद्यार्थी तुमच्या क्लासमध्ये. मुळात तुम्ही लक्ष देताय का नाही ह्याच्याबद्दलच मला शंका येते क्लासमध्ये, की बाबा तुम्ही लेक्चर चालू करून लक्ष देताय का निवांत बसताय. मागे एकदा मी तुमची मेसेज टेस्ट घेतली होती, निम्म्यार्थी विद्यार्थ्यांनी तर काय आन्सरच दिला, रिप्लाय दिला नाही. दे वर नॉट एबल टू. आता सी अजून हे कोण तर आता मधूनच जॉईन व्हायला लागले. इतक्या वेळ त्यांनी काय अर्धा तास झोपले का होते काय माहित काय केलं. एक तर विद्यार्थी मागच्या वेळेस मी फोन केला ना पेरेंट्सला, तो मुलानं फोन उचलला आणि तो मुलगा कुठं होता तर गाडीवरती फिरत होता, काहीतरी महत्वाचं काम होतं. म्हणजे फिजिकली कॉलेज प्रेझेंट असताना तुम्ही प्रेझेंट करताय आणि इतर वेळेस तुमची कामं महत्वाची असतात. त्यावेळेस कामाला प्रायोरिटी, शिकायला प्रायोरिटी नाहीये. सी, यू आर वेस्टिंग युअर टाइम, यू आर लुझिंग युअर व्हेरी व्हॅल्युएबल टाइम, करिअर अपॉर्च्युनिटी. हे जर तुम्ही असं जर वेस्ट केला तर इट इज व्हेरी डिफिकल्ट. Once upon a time, I have told you to listen, to watch the speech of that Lahani, Dr. Lahani, विठ्ठलराव लहानी. ओके, ज्याने ऐकले त्यांना कळालं असेल त्याचं संधीची गोष्ट काय आहे ती, संधी कशाला म्हणायचं. आणि आयुष्यामध्ये संधी ही सारखी येत नसते. सारखी येत नसते म्हणजे तुमच्या करिअर, तुमचं जोपर्यंत टीचिंग चालू आहे, लर्निंग चालू आहे, तोपर्यंतच तुम्हाला ती संधी असते. वन्स यू गेट आउट ऑफ दिस फेज ऑफ द लर्निंग, विद्यार्थी दशेमधून ज्यावेळेस तुम्ही बाहेर पडाल त्यावेळेस तुम्हाला घरचे नाही, कोणच तुमचं ऐकणार नाही. की तुम्हाला अजून परत शिकायचं असेल किंवा काय जरी तुम्ही केलं तर तुम्हाला कोण ऐकून घेणार नाही. पेरेंट्स आर पेइंग ह्यूज फीज, दे नो हाऊ दे आर अर्निंग द मनी, राईट. तुम्हाला अजून काय माहित नाही ते पैसा कसा कमावला जातो किंवा किती कष्ट असतं त्याच्याबद्दल. आणि तुम्हाला जर त्याची जाणीव असली असती तर तुम्ही असं बिहेव केलं नसतं, दो स्टुडंट्स. आणि एकदा वेळ हातातून निघून गेली तर मग परत काहीच उपयोग नसतो हे करण्यामध्ये. काम होतं म्हणून सांगताय, काय काम असणार तुमच्या विद्यार्थी दशेमध्ये, तुम्हाला कोण काय काम होतं एवढं महत्वाचं.
हॉस्पिटलमध्ये गेलो.
ठीक आहे ना, तुमचं एक वैयक्तिक असं काहीतरी एखादं असू शकतं एखाद्याचं, पण बाकीची मुलं किती प्रेझेंट आहेत सांगा मला. तुमच्या क्लासमध्ये 26-46 विद्यार्थी प्रेझेंट आहेत. क्लास आहे तुमचा 70चा का 80चा क्लास आहे. व्हॉट ऑदर दे आपल्या शिकण्यापेक्षा काय महत्वाचं काम करतात ते मुलं मला माहित नाही. What they are doing, where they are investing their valuable time. आणि जे काही लेक्चर लॉग इन करून बसलेले आहेत, जे काही प्रेझेंट आहेत, आउट ऑफ दिस स्टुडंट्स ऑल्सो हाऊ मच सिरियसली द स्टुडंट्स आर लिसनिंग टू द लेक्चर्स. आपल्याकडे कारण हजार असतात सांगायला लेक्चर न करण्यामागं किंवा न ऐकण्यामागं, पण हे नंतर कोण ऐकणार आहे तुमचं. एकदा तुमची ह्या फेज मधून तुम्ही बाहेर पडल्यानंतर तुमचं कोणच ऐकून घेत नाही असल्या गोष्टी. इव्हन आई वडील पण आपल्याला हे करत नसतात नंतर. सो बी सिरियस. एक सिंपल तुम्हाला प्रश्न विचारलाय, काय खूप अवघड असलेलं पण भाग नाहीये. हा फॉर्म्युला पण आता शिकलोय मी, रिपीट केलेला.
सर मी चॅट बॉक्स मध्ये सांगितले माझ्याकडे रेंज इश्यू, मी आन्सर टाकलेलं चॅट बॉक्स मध्ये.
अहो चॅट बॉक्स मध्ये तुम्हाला अनम्यूट करून सांगता येत नव्हतं का. चॅट बॉक्स मध्ये प्रत्येक वेळेस आता मयुरीने टाकले, परत श्वेता, यू कॅन अनम्यूट युअर सेल्फ ना. काय सांगायला तुम्हाला म्हणजे हे वाटतं का काय बोलताना वगैरे, HF = 4f² एवढं टाईप करत बसण्यापेक्षा एक सेकंदामध्ये सांगितलं असतं की उत्तर एखाद्याने.
नाही सर, घरात जरा नॉईज असतो मग ते सगळं ऐकायला जातं.
ठीक आहे, मग घरच्यांना सांगत जावा ना त्यांना, लेक्चर चालू असताना तुम्ही हे करत जाऊ ना किंवा दुसऱ्या ठिकाणी कुठं तर बसत जावा. म्हणजे ते घरचे पण सिरियस नाहीत का तुमच्या ह्याच्याबद्दल. आता काही विद्यार्थ्यांच्या बाबतीत होतं तसं, काही विद्यार्थी चालू केल्यानंतर आता ते मग फोन होतं जाधव त्यांनी पण तेच सांगितलं, श्वेता जाधव, घरून आवाज येते. म्हणजे घरच्यांना तुमच्या अभ्यासाबद्दल काळजी नाहीये, सिरियसनेस नाहीये त्यांच्या तुमच्या ह्याच्याबद्दल. दे शुड. तुमचं ज्यावेळेस लेक्चर चालू असतं त्यावेळेस तुमच्या जवळ आसपास त्या ठिकाणी कोण नसायला पाहिजे. इट क्रिएट द डिस्ट्रॅक्शन. तुमचं लक्ष तर कसं लागेल त्यावेळेस त्या केसमध्ये. तुम्ही त्यांना घरच्यांना समजावून सांगणं गरजेचं आहे ना, त्यांना जर कळत नसेल तर. किंवा मग अशा ठिकाणी तुम्ही जाऊन बसलं पाहिजे ज्या ठिकाणी आवाज गोंधळ येत नाहीये. ही लेक्चर अटेंड करण्याची सगळ्यात महत्वाची सगळी गरज आहे, सगळ्यात महत्वाची, की बाबा ज्या ठिकाणी गोंधळ नाहीये, डिस्ट्रॅक्शन्स नाहीत, अशा ठिकाणी जाऊन बसणं लेक्चर ऐकणं. बरोबर आहे. सो कशाही परिस्थितीमध्ये आपल्याला जर ते अनअवॉइड करता येत असेल, अवॉइड करता येत नसेल, तर त्या केसमध्ये चॅटबॉक्सचा वापर केलेला ठीक आहे. उत्तर पण तुम्ही लगेच दिलं तर उत्तर तुमचं रेशमा साधी दिली. I was asking many times and after repeatedly asking, some students have put their answers in the chat box. मी तुम्हाला असं हलवावं लागतं, तुम्हाला जागा करावं लागतो, जपीत नोटल्यासारखं. प्रश्नाचं उत्तर द्या, उठा, प्रश्न विचारलाय. Such kinds of behavior, it is not expected from your side. Okay, yes, who will tell now? HF is equal to what?
HF is equal to 4F into L into V square upon D into 2G.
D into 2G or 2ZD, also you can say like this. Okay, this is the formula for Darcy's equation. Now, whether they have given the value of F ची व्हॅल्यू दिलेली नाहीये. ठीक आहे, एफ दिलेलं नाहीये म्हणजे आपल्याला आधी काय करावं लागेल, एफ काढावं लागेल. एफ काढण्यासाठी काय फॉर्म्युला आहे, आपल्याला रेनॉल्ड्स नंबर आपल्याला अगोदर काढावा लागेल. We have to check whether by using that Reynolds number, what is the value of Reynolds number. Depending upon that Reynolds number, we have to choose appropriate formula for finding the F. Reynolds number चा काय फॉर्म्युला आहे, रो व्ही डी अपॉन म्यू, हा फॉर्म्युला आहे. ठीक आहे, त्याच्यामध्ये आपल्याला रो माहित आहे, व्ही माहित आहे, डी माहित आहे. वेदर डू यू नो द व्हॅल्यू ऑफ म्यू नाही माहित. अजून एक आपला फॉर्म्युला आहे, हा जर रो आपण खाली घेतला तर काय होईल, म्यू अपॉन रो होईल. आठवतंय का तुम्हाला फॉर्म्युला हा काय, म्यू अपॉन रो म्हणजे काय आहे ते, किती जणांना आठवते बघूया आपण. व्हॉट इज दिस म्यू अपॉन रो, काय म्हणतो आपण त्याला,
कायनेमॅटिक.
येस,
न्यू
त्याला न्यू कायनेमॅटिक विस्कोसिटी, राईट. So this VD upon nu is also formula. So V is how much? V is 3 into D 0.3 divided by nu दिले आपल्याला, स्टोक्स मध्ये दिले. कन्वर्ट करा, स्टोक्सचं सेंटीमीटर मीटर स्क्वेअर पर सेकंड मध्ये कन्वर्ट करायचं. हाऊ मच इट विल बिकम, काय फॉर्म्युला आहे स्टोक्सचं कन्व्हर्जन करणार ह्याच्यामध्ये करायचं असेल तर
1/10.
1/10. Is it the formula?
1/100.
Yes. 1 upon see how much we are doing study seriously. Into 10 to the power what?
Into 10 to the power -4.
-4.
-4.
10 to the power -4. Correct. Now put this value here in this formula. 0.01 into 10 to the power -4. Okay, and find out how much it will come. 0.03 काय इथं दिसत का नाहीये, असं व्हायला लागलं, ब्लॅक काय लागले. RE is equal to VD upon mu. 0.01 आहे ना. हाच प्रॉब्लेम सोडतोय आपण.
Yes, sir.
Yes.
Yes, sir.
0.01 या ठिकाणी टाकून द्या 10 to the power minus 4. You will get R is equal to 9 into 10 to the power 5. Okay. RE ची व्हॅल्यू किती आली? 9 into 10 to the power 5 is the value of Reynolds number. Now from this value you will get idea whether the flow is laminar flow or turbulent flow. What kind of flow it is? कोण सांगेल? लॅमिनर फ्लो आहे का टर्बुलंट फ्लो आहे? When we call the flow as a laminar flow, आता हे पण माहिती
Turbulent phase.
कसं व्हायचं तुमचं यार अवघड आहे. लॅमिनर फ्लो आणि टर्बुलंट फ्लो रेनॉल्ड्स नंबरच्या टर्म्स मध्ये तुम्हाला सांगता येत नाहीये. When we call the flow as a laminar flow, when the value of Reynolds number is less than
Less than 2000.
less than 2000, मग कधी सांगणार आहे तुम्ही उत्तर? का असं बसतंय तुम्ही निवांत आयडियल? हा बोला की सर. Okay. So what kind of flow it is?
Turbulent.
Turbulent.
Correct.
Turbulent.
Flow is turbulent flow. So turbulent flow असेल तर त्या केस मध्ये आपण काय फॉर्म्युला करणार आहे? दिस फॉर्म्युला टर्बुलंट फ्लोचा फॉर्म्युला आपण एफ चा लिहून घेतलेला आहे. कुठे लिहिलेला आहे आपण आठवतं तुम्हाला? बघा नोटबुक मध्ये तुमच्या. F is equal to 0.079 upon R raised to 1 upon 4. Is it there? Then use this formula and find out the value of F. Coefficient of friction ची व्हॅल्यू फाइंड आउट करा. F is equal to 0.079 टाकून त्या ठिकाणी. आणि एकदा तुम्हाला F ची व्हॅल्यू भेटली तर आपल्याला HF चा फॉर्म्युला त्या ठिकाणी वापरता येईल. आणि HF चा फॉर्म्युला भेटल्यानंतर तुम्हाला हे करता येईल. HF चा फॉर्म्युला करून HF ची व्हॅल्यू काढता येईल. ठीक आहे. तर अशा पद्धतीने HF ची व्हॅल्यू काढा आणि त्याच्यानंतर आपण चेझिस फॉर्म्युला करून सेम उत्तर त्या ठिकाणी आपण काढणार आहोत. ठीक आहे. सो डू इट फास्ट. Yes, how many students have got the answer? 0.78. Mayuri, what we have found is 2.5 into 10 to the power minus 3.
F.
F, okay. Okay, those students who have got the answer for HF by using Darcy equation, then you can find by using Chezy's formula. What is Chezy's formula? Chezy's. Chezy's formula. V is equal to, yes, who will tell what is formula? V is equal to
C under root of RS.
under root of RS or C into under root of MI. Now, whether we know the value of C? Yes, C is given. C is equal to how much?
60.
60. Then R. R is nothing but it is A by P or D upon 4. How much is the diameter?
0.3.
0.075.
What is 2GT? 2GT. Is it the velocity? This diameter?
0.3.
0.3. 0.3. Here taken 0.3 D. 0.3 by 4 is equal to
0.075.
0.075.
R. It is will be unit will be meter. It is depth, hydraulic radius or hydraulic mean depth. Unit kasnar is a meter. Then S. S is equal to what? HF upon L.
L.
So here, first of all, let us find out S. Okay. Velocity दिली का आपल्याला? Problem मध्ये velocity दिली आहे का?
Yes, sir.
How much it is?
3 meter.
3 meter per second. Or 3 meter. Meter मध्ये असते velocity.
3 meter per second.
3 meter per second.
3 meter per second. So now use this formula. Velocity equal to 3 meter per second. C is equal to how much? 60 under root of R is equal to how much we have found? 0.075 into S. Now we have to find out what is the value of S. Okay. Now you can do the square on both sides. What will come here? 9. What will come here? 3600 into 0.075 into S. Therefore, S is equal to how much? Square by 0.075.
0.033.
This is the value of S, right? As S is the slope, so it will not have the unit. Okay, because here it is in meter, it will be in meter. Meter will get cancel and will not have unit. So S is equal to 30, 0.033. Then we can write HF divided by L is equal to 0.033, right? Therefore, HF will be equal to 0.033 into L. What is the length given? Length of pipe?
50 meter.
0.033 33 into 50 is equal to, multiplied by 50,
1.65.
667. This will be the meter. So this is the answer for this. So we can compare the head loss. या ठिकाणी Darcy-Weisbach formula वापरून आपल्याला head loss आलेला आहे 0.78 and या ठिकाणी आलेला आहे 1.66. So या ठिकाणी head loss Chezy's formula आणि head loss ची value जास्त आली आहे 1.667. Yes, you can see here 1.667 or 666. This is the answer that we have got by using the Darcy-Chezy's formula, and this is by Darcy-Weisbach equation. Okay. Everyone got this answer?
Yes, sir.
Okay, next problem, write down. Find the diameter of pipe of length. Find the diameter of pipe of length 2000 meter. 2000 meter. When the rate of flow of water, when the rate of flow of water through the pipe is 200 LPS, liter per second. LPS, liter per second. And head loss due to friction is, and head loss due to friction is 4 meter. Is 4 meter. Full stop. Take the value of C is equal to 50. Take the value of C is equal to 50 in Chezy's formula. In Chezy's formula. This is the problem. काय काढायचं आहे? Find the diameter of the pipe. Pipe ची diameter काढायची आहे. Length दिलेली आहे. So first of all, write down all the given things. L is equal to 2000 meter. Rate of flow means discharge Q is given. (200 LPS). Head loss HF is given 4 meter. C is equal to 50. Okay. And what we have to find out? We have to find out the diameter. So C is given means we have to use the Chezy's formula. What is the formula? Chezy's formula. V is equal to C into under root of RS. Okay. Now whether velocity is given, not given, but what they have given, discharge. So Q is equal to 200 LPS means meter cube per second का 0.2 meter cube per second. कसा 0.2 dividing this value by 1000. का 1000 ने डिवाइड करतोय? लिटरचं क्यूबिक मीटर मध्ये आपण कन्वर्जन करायचं असेल तर 1000 ने आपण डिवाइड करतो. Q is equal to 0.2 meter cube per second. We know that velocity is equal to discharge upon area, right? Because कारण Q चा आपल्याला फॉर्म्युला आहे Q is equal to A into velocity. Q is equal to A into V. So therefore V is equal to Q upon A is equal to, कोण आहे ते participant? So V is equal to Q upon A. Q किती आहे 0.2. What is area? डायमीटर दिले आपल्याला, डायमीटर दिलेलं नाहीये. ठीक आहे, मग इथं काय लिहायचं, π/4 इंटू d स्क्वेअर. हे 4 वरती जाईल. ठीक आहे, म्हणजे इथं काय आलं πd स्क्वेअर आलं. इथं किती आलं वरती 0.4 का 0.8 येईल. ठीक आहे, मग हे व्ही आहे तसं ठेवायचं. आपल्याला डायमीटर काढायचे, हे काढायचे. नेक्स्ट सी किती दिलेलं आहे 50 इंटू आर किती आहे, आर पण आपल्याला दिलेलं नाहीये. आर इज नथिंग बट इट इज d/4. so here you can write d/4, right? And then s, how much s is given? स्लोप दिलेला आहे आपल्याला, प्रॉब्लेम मध्ये दिलेलं नाहीये, पण काय दिलंय HF दिलेलं आहे. व्हॉट इज एस, कोण सांगेल एस काय आहे? बोला रे,
HF
upon L.
HF अपॉन
L.
बरोबर आहे. सो HF आपल्याला दिलेलं आहे 4 मीटर, लेंथ दिलेली आहे 2000. सो व्हॉट विल गेट हियर, divide it 4/2000. How much it come? 2 into
10 raised to -3.
10 to the power -3. ठीक है. So now put this value in this equation. V is equal to now 0.8 by pi into d square is equal to C value is 50 into under root of d/4 into 2 into 10 to the power -3. Okay. Now take the square on both sides. Do the square on both sides, or first of all take this 50 here on this side. That will become go in denominator, and then do the square on both sides. Square करा, square केल्यानंतर आपल्याला या ठिकाणी काय भेटेल, d/4 into 2 into 10 to the power -3. ठीक आहे, या साईडला काय येईल 0.8 divided by pi divided by 50. You will get 0.05 divided by d square bracket square. ठीक है, पॉइंट याचा स्क्वेअर करा, काय येईल 2.59 किंवा 2.6 म्हणूया 10 to the power -3 divided by d to the power काय येईल 4 is equal to d/4 into, आता हे d पण इकडे घेऊन जावा किंवा हे d इकडे आणा, हे d to the power काय होईल 5 होईल. ठीक आहे, इकडे गेल्यावर d, हे d to the power 5, हे डिनॉमिनेटर मध्ये तिकडे गेल्यावर काय होईल न्यूमरेटर मध्ये जाईल, हा पार्ट काय होईल डिनॉमिनेटर मध्ये जाईल. Do that simplification. 10 to the power -3 गुणिले 4 भागिले 2 into 10 to the power ब्रॅकेट टाकायला लागेल 2 into 10 to the power -3 ब्रॅकेट complete is equal to 5.18 raised to 1/5. It will come d is equal to 1.389. Do the simplification and tell your answers whether what answer you are getting. Wait first. It is coming 0.553 meter. Something has gone wrong.
0.5533.
Hmm. Do the calculation and tell your answers. It is quite simple part. Just do the calculation part. Meaning, then remaining part is quite simple. Just simplification. 5.526.553.526. Okay, others put your answers quickly in the chat box. Wait first. Is it over? Okay. From boys side, anyone? सायली मग तुम्ही बाहेर का पडताय सारखं?
सर रेंज आजचे
रेंज
सर रेंज
बर. सुयश हुबळे, तुम्ही आता जॉईन झालात का सुयश? रोल नंबर 43. सुयश, he has left the session. Okay, many students have got the answer, so let us move ahead. Minor losses now we will see. Okay. Major loss आपण शिकलेलो आहोत. Major loss is nothing but it is head loss due to friction. And how to find out that? By using two formula, we have learned that how to find the head loss due to friction. One formula is the Darcy-Weisbach equation, and second formula is the Chezy's formula, right? Chezy's Darcy-Weisbach equation, it is nothing but it is HF is equal to 4FL square upon 2GD, and Chezy's equation is nothing but it is V is equal to C into under root of RS. By using that two formulas, we have solved the problems based upon it. So let us now learn what are the various major losses, minor losses. Okay, the loss of head due to the change in magnitude or change in direction of the velocity, that type of loss is called as the minor losses. Okay, the loss of head or energy due to the friction in the pipe is known as the major loss, while the loss of energy due to the change in the velocity of the flowing fluid in magnitude or direction is called as the minor losses. Velocity मध्ये जर बदल झाला either in magnitude मध्ये किंवा त्याच्या डायरेक्शन मध्ये, त्याच्यामुळे होणारा जो लॉस आहे that loss is called as the minor loss. Okay, minor loss of energy it includes the following cases. Minor loss जो आहे त्याच्यामध्ये following cases या ठिकाणी असतात. What are that various minor losses? First one is the head loss due to sudden enlargement. Head loss due to sudden enlargement, it is also called as this head loss due to sudden expansion. Okay. Second one is the head loss due to sudden contraction. Head loss at the entrance of the pipe, head loss at the exit of the pipe, loss of head due to the obstruction in the pipe, loss of head due to the bend in the pipe, and loss of head due to the various pipe fittings. These are the various types of losses that we are going to see it in details one by one. In case of the long pipe, above losses are very small as compared to the loss of head due to the friction, and hence they are called as the minor losses. मोठा जर लॉंग पाईप असेल तर लॉंग पाईप मध्ये काय होतं, त्याची लेंथ खूप वाढलेली असते, पाईपची लेंथ जास्त असल्यामुळे त्या ठिकाणी होणारा जो हेड लॉस आहे हा हेड लॉस ड्यू टू फ्रिक्शन हा खूप जास्त असतो ॲज कम्पेअर टू दी मायनर लॉसेस. ओके, ह्या लॉसेसमुळे होणारा जो लॉस आहे तो खूप मायनर असतो. दॅट्स वाय त्या लॉसला आपण काय म्हणतो मायनर लॉसेस म्हणतो. ह्या जे लॉस आहेत त्यांना आपण काय म्हणतो मायनर लॉसेस. अँड समटाइम दे आर अँड इवन मे बी निग्लेक्टेड, समटाइम दे आल्सो निग्लेक्टेड विदाउट एनी सिरियस एरर, ते आपण निग्लेक्ट करू शकतो. बट इन केस ऑफ शॉर्ट पाईप, जर पाईपची लेंथ लहान असेल त्या केसमध्ये वी नीड टू कन्सिडर दिस मायनर लॉसेस ऑल्सो अलॉंग विथ दी major loss, that is head loss due to friction. Okay, so let us see it one by one now. Loss of head due to sudden enlargement. Okay, so before going in details, write down the title there and simultaneously we will write down the formulas. Write down the title minor losses. Write down the title minor losses. Write down there the loss of energy due to the change of velocity. Loss of energy due to change of velocity of flowing fluid. Change of velocity of flowing fluid in magnitude or direction. In magnitude or direction is called minor loss. Is called minor loss. Next, खाली लिहा sentence. The minor loss of energy or loss of head. Minor loss of energy includes the following cases. Minor loss of head, loss of energy includes following cases. First case, loss of head due to sudden enlargement. loss of head due to sudden enlargement. Second, loss of head due to sudden contraction. Then third, loss of head at the entrance of pipe. Next, loss of head at the exit of a pipe. Loss of head due to an obstruction in a pipe. Next, loss of head due to bend in the pipe. Due to bend in the pipe. Last one, loss of head in various pipe fittings. Loss of head in various pipe fittings. Then write on the first title, loss of head due to sudden enlargement. Loss of head due to sudden enlargement. Loss of head due to sudden enlargement. Draw this diagram. In this diagram, you can see there are two different diameter pipes. First pipe is of the diameter D1, area A1, and there is second pipe of diameter D2, area A2. There will be velocity V1 here, here V2, pressure P1 here, pressure P2 here. Okay. Draw the diagram. Now, if when water flows from smaller pipe to larger pipe, at that time, due to the high velocity, cross-section area velocity just the same. This water will be thrown like this. It will try to flow like this, and there will be a cavity will be formed here. Okay, या ठिकाणी काय होतं, एक cavity किंवा open space create होतो, and this water will try to move like this in this particular space. In this cavity will be try to get filled, and due to these whirls, this is called like the whirlpool, like that. Whirl, it will form. Okay, reverse current in this particular pocket, आणि याच्यामुळे या ठिकाणी काय होतो, head loss it will occur there, and this loss is given by this equation. Okay, loss due to the sudden enlargement. He is equal to, write on the formula, He is equal to V1 minus V2 bracket square, V1 minus V2 bracket square divided by 2g, divided by 2g, where V1 is the velocity of flow at section 1,1 or at smaller diameter pipe. At smaller diameter pipe, V2 is equal to velocity of flow at section 2,2 or at larger diameter pipe. Everyone, is it over? Yes. Everyone have written this formula, have drawn the diagram. Give the quick reply.
Yes, sir.
Okay, then let's move ahead. Next, write on the title, loss of head due to sudden contraction. Loss of head due to sudden contraction. Draw this diagram, section 1, 2, C. See, when water flows from larger pipe to the smaller pipe to smaller pipe here, at that time, it is trying to move like this. Okay. And again, here, air pocket will form, space will form, where the walls are going to, eddies are going to appear there. And due to that, there will be loss of head. It will occur here. And this loss of head is called as the head loss due to sudden expansion. Okay, which is given by this equation. Write on this equation. Hc is equal to v2 square upon 2z. V2 is the velocity here in the smaller pipe. V2 square upon 2z into 1 upon cc minus 1 bracket square, where cc is equal to AC upon 2, that is coefficient of contraction. Cc means area at this particular section divided by A2. Okay, divided by A2, that is coefficient of contraction. Cc is equal to AC upon A2. Then, instead of this part, we can write K. Many times, this value of K is taken as 0.5. If the value of C is not given, जर C ची value दिलेली नसेल, ठीक है, then we cannot find it easily, the value of HC. So instead of that, then head loss due to contraction is taken as, so instead of this value, we take 0.5. Okay. So write down the formula, this formula we are going to use many times. Okay. For the head loss due to sudden contraction, we are going to use this formula because many times they don't give the value of Cc. And by using this formula, it is difficult to find out what is the value of Hc. So we take this average value 0.5. Hc is equal to 0.5 v square upon 2z. Is it over?
Yes, sir.
Okay. Next, loss of head at the entrance of pipe. Loss of head at the entrance of pipe. So here the diagram is not given, but you can draw the diagram like this. Suppose this is the container. Okay. And this is the pipe. So if you look at this particular this section, water is moving like this, and it is moving like a contraction here. Like head loss due to sudden contraction मध्ये कसं होतं, लार्जर पाईप मधून स्मॉलर पाईप मध्ये जाताना या ठिकाणी काय व्हायचं, अशा पद्धतीचं कॉन्ट्रॅक्शन होतं. ओके, CC, coefficient of contraction, it was observed here. So therefore we can use the same formula, that is of the head loss due to sudden contraction. Okay, V is the velocity in the pipe. You can write HI is equal to 0.5 V square upon 2Z. V square upon 2Z. Next, write down the title, loss of head at the exit of pipe. Loss of head at the exit of pipe. So what happens at the exit of pipe? At the exit of pipe, total complete velocity is lost. Okay, whatever will be the head is there, that total head, it is going to lost here when the water comes out through the pipe. So what is the velocity here? It is the V. So total kinetic energy is being lost here. So this kinetic head can be represented by little V square upon 2Z. So this is the head loss at the exit of pipe, it will occur there. So here you can write down the equation for loss of head at the exit of pipe as H0 is equal to V square upon 2Z. H0 is equal to V square upon 2Z. This is the head loss at the exit of the pipe. Have you noted these formulas? Is it over?
Yes, sir.
Okay. Then next, write down. Loss of head due to an obstruction in a pipe. Loss of head due to an obstruction in a pipe. Suppose this is a pipe, water is flowing through this pipe, and there is some obstruction like this in between the flow. Then this is going to create the head loss. Okay, and this head loss, it is similar to the head loss at the sudden contraction, because suddenly या ठिकाणी काय होतं, एरिया कॉन्ट्रॅक्ट झालेला असतो, फ्लो जो आहे फ्लो या ठिकाणी रिड्यूस होतो एवढा, राईट. There is a sudden enlargement of an area of flow beyond the obstruction due to which loss of head takes place as shown in figure. आणि याच्या पुढे सडन एनलार्जमेंट होते ना, या ठिकाणी एरिया वाढतो अचानक, राईट. Now here directly write down this formula. Loss of head due to obstruction is equal to loss of head due to obstruction is equal to V square upon 2Z. Capital A divided by CC into A minus capital A minus small a, bracket complete minus 1, bracket square. Where here capital A is equal to area of pipe capital A is equal to area of pipe, small a is equal to maximum area of obstruction. Small a is equal to maximum area of obstruction. And CC, as usual, CC is equal to coefficient of contraction. Everyone have written this formula? Yes.
Yes, sir.
Write down next, loss of head due to bend in pipe. Loss of head due to bend in a pipe. Write down the formula, HB is equal to KV square upon 2Z. KV square upon 2Z. Where K is equal to coefficient of pipe fitting. K is equal to coefficient of bend, not pipe fitting. Coefficient of bend. Where the value of K depends on first angle of bend, radius of curvature of bend, radius of curvature of bend, diameter of bend, diameter of bend, diameter of pipe, not bend. Next, write down loss of head in various pipe fittings. Loss of head in various pipe fittings. So it is given as K into V square upon 2Z, where K is equal to coefficient of pipe fittings. Coefficient of pipe fittings. Is it over? Now here we are going to solve problems based upon these minor losses. So take your notebook. Write down the problem. Find the loss of head. Find the loss of head when the pipe of diameter 200 mm, when the pipe of diameter 200 mm is suddenly enlarged, mm, to a diameter of 400 mm. The rate of flow of water through the pipe is 250 liter per second. So first of all, write down the given things. Given. Find the loss of head when the pipe of diameter 200 mm suddenly enlarged diameter pool. So diagram will be like this. This is section 1, section 2. D1 is equal to 200 mm, means 0.2 meter. dt is equal to 400. Zero 0.4 meter. So what is the formula for sudden expansion? H is equal to yes. What is formula? H is equal to what?
V1 minus V2 bracket square upon 2G.
What is V1? Velocities दोन दिलेत का? विचार दिलाय. We need to find out the velocities. V1. Yes. Q is equal to A into V. V is equal to Q by A. Putting this discharge 250 divided by area A1. How much is the velocity? V1 and V2. Yes, what is the value of V1, V2? सोडवते की नाही कोण?
Hello, sir.
Only 4 students have put the answers.
Sir, V1 is 7.96 and V2 is 1.99.
Okay. So let me check here. Correct. H is equal to 1.816. Correct. Mayuri has got the answer. What about other students? H is equal to 1.816. Correct. 1.816 is the correct answer. Okay, many students have got the answer. Now let us move ahead to solve the next problem. See, this question was asked in December 2015 for 4 marks and in December 2015 for 3 marks. तर हे एक बॅकलॉगचा पेपर होता आणि एक रेग्युलर पेपर, या दोन पेपर मध्ये हा सेम टाइपचा प्रॉब्लेम पडलेला. रवी सेशन आता जॉईन केलं का तुम्ही? रवी, वेर यू वेर किंवा रवी मस्त होत, अनम्यूट युअरसेल्फ.
हॅलो सर.
कुठं होता तुम्ही इतके वेळ?
सर मोबाईलचं रिचार्ज संपलेलं सर, परत टाकायला गेलो बाहेर.
रिचार्ज संपोस तर बसलात तुम्ही, सकाळी टाकलं नाही का?
न सर, सकाळी 12 वाजता संपलं सर. परत
Okay, next, write down the problem. This problem is based upon the head loss due to head loss due to the obstruction in the pipe. Okay. Water is flowing through horizontal pipe of diameter 200 mm. Water is flowing through a horizontal pipe of diameter 200 mm at a velocity of 3 meter per second. At a velocity of 3 meter per second. To stop a circular solid plate of diameter a circular solid plate of diameter 150 mm is placed in the pipe to obstruct the flow. To obstruct the flow. To stop, find the loss of head due to obstruction. Find the loss of head due to obstruction in the pipe. Due to obstruction in the pipe if Cc is equal to 0.62 0.62. So let us write down the given things. Let's use the capital letter for the pipe and a small letter for the obstruction. So capital D will be the diameter of the pipe and small d will be the diameter of obstruction. Then capital A will be the area of pipe and small a will be the area of obstruction. Right. And velocity v is given 3 meter per second. Write down that. Cc is given. Cc is equal to 0.62. Formula for loss of head due to obstruction is equal to v square upon 2z in bracket capital A upon Cc into capital A minus small a minus 1 bracket square. Put the values in the formula and find the answer. Whether you are getting the same answer or not, let me know. Put your answers in the chat box. I'll take your attendance. हरी वस्तू I have taken your attendance now. 3.315. 3.311. That is the answer. Okay. Many students have got the answer. Mayuri, Shweta, then Reshma, Rohini, Sakshi. All the answers are correct. Other student, do it first. Our next point is hydraulic gradient and total energy line. So this point we are going to see in the next lecture. Okay. Today we will stop here. Up to this much only, because if we take this next point, it will become much more heavy dose for today. So पुढच्या लेक्चर पर्यंत हे मागचे सगळे फॉर्म्युले सगळ्यांनी पाठ करायचे. मेजर लॉस आणि मायनर लॉस हे दोन्ही मधले जेवढे काही फॉर्म्युले आहेत ते सगळे फॉर्म्युले पाठ पाहिजेत आपले. मेजर लॉस मधले तुमचे दोन फॉर्म्युला, डार्सी-वेईसबेक इक्वेशन पाठ पाहिजे तुमची आणि चेझीज इक्वेशन, या दोन इक्वेशन पाठ पाहिजे. त्यानंतर मायनर लॉस मध्ये आपण जे काही मायनर लॉस बघितले, जसं की हेड लॉस ड्यू टू सडन एक्सपान्शन, हेड लॉस ड्यू टू सडन कॉन्ट्रॅक्शन, head loss due to obstruction, head loss at the entrance, head loss at the exit, head loss due to the bends, and head loss due to the fittings. एक 7 प्रकारचे जे मायनर लॉस आहेत सगळ्यांचे फॉर्म्युले आपल्याला पाठ पाहिजे. ठीक आहे. हे फॉर्म्युले महत्त्वाचे आहेत. परीक्षेमध्ये याच्यावरती प्रश्न येतो, विचारला जाऊ शकतो, आणि ओरल मध्ये पण याच्यावरती प्रश्न विचारला जाऊ शकतो. ठीक आहे. एव्हरीवन मस्ट बाय हार्ट दिस फॉर्म्युलेज. From the boys side, no one has put the answers in the chat box. What is the problem? Ashish Atkale, Chaitanya Chandole, Rohan Chavan. What are you doing there? Are you solving the problem or not? Yes, there is no response from your side. Ashish Atkale, are you there?
Yes, sir. Solving, sir.
Chaitanya Chandole.
Yes, sir.
Have you solved the problem? Problem सोडवला का?
नाही सर.
सोडवा लवकर. Those students who have solved the problem, they can leave the session. Have taken your attendance. On boy side only Rushikesh Survasi, he has put the answer. Now Sunny Kachari has put. Okay, now let us stop here. We'll end this session here. I have taken your attendance. Now we can leave the session.